guys, so you've done introduction to random variables, so this will just be a summary, a quick summary. So the first thing that I'm going to talk about is the CDF, which you know as the cumulative distribution function. So you know that the CDF, it's never negative and it's either equals to 0 or the maximum it can get to is 1, right? So we have that. Okay, this is the cumulative distribution function for xi. We know that it is the probability where x is your random variable, is less than or equals to xi. It just means that you are going to add up all the probabilities available to you until you get to the probability of this number. So we have this expression here. This expression is used to check what random variable are we dealing with. So if you are given a random variable and they did not tell you that it's discrete or continuous or whatever, you are going to check, and if you get 1, you know that your RV is discrete. If you get 0, your RV is continuous, and so on, right? So this is the expression you use to check. So again, so you discussed discrete and continuous RVs, random variables. So we know that, okay, f of xi is our probability distribution, or is the probabilities, they are greater than or equals to 0. So the summation of all these equals to 1. So under discrete we have the probability mass function, right? So under the probability mass function, we know that when you add all the probabilities you should get 1, and we know that, okay, the probability, so we know that fxi equals to the probability of x, the random variable, when x equals to xi. So this is the expression for solving this. So how they came up with that expression is that when okay, your x, when your random variable has x1, x2, x3, and x4, and these are the probabilities, and then we also have the CDF this side. So we know that okay, the capital F stand for the CDF, and the small f stand for probability. So we know that, okay, to get your cumulative distribution function, you know that you have to add the probabilities, right? So okay, f xi will be f of x1, the probability here, and then this one, this here will be this plus this, so on. So we keep on adding. So to explain that formula, so let's say the CDF at x4, we know that we are going to add the probability at x1, 2, 3, and 4. So this is the same as saying the CDF at x3 plus the probability of x4. So to get this probability, we know that we are going to say the CDF at x4 minus the CDF at x3, right? So when we get to continuous RV, we know that also, okay, we are going to talk about the probability density function now. We know that it is greater than 0, and when you integrate from negative infinity to infinity, you will get 1. So we know that thus here the probability of x greater than or equals to a less than or equals to b equals to the integration from a to b of the probability density function dx, right? So they are saying that this is the same as saying this, whereby you'll get that it's the probability of b minus probability of a. So the reason they said that this expression equals to this one, it's because under continuous RV, the probability of when the random variable x equals to 0, because under continuous RV we are integrating, so it's like we are finding the area under a graph. So so when we have a graph like this, so we can see that when we get to x, we just have a straight line, so the area will be 0, right? The area will be 0. So the CDF of this, we know that the CDF at x will be, you will integrate from negative infinity until x, and then you will just integrate the given probability density function. So to get the probability density function given the CDF, you know that you are going to differentiate the CDF by dx, so it's going to be df of x divided by dx, right? So talking about the mean and the variance, so getting the expected value, which is the mean, for a discrete random variable, you are going to sum x times f of x, where f of x is your probabilities. You will see when we do an example, and this is how we find the variance. I'm sure you have these formulas and you've seen how they derived them. So yeah, I'm just showing them to you so that I can show you the difference between discrete and continuous variables. So when given a function that, okay, this function equals to ax plus b, when you are finding the expected value of this function, you are going to say it's a, then the expected value of x plus b. And then for the variance, you're going to say it's a squared times the variance of x. So you need to know that the variance of a constant equals to 0, and the expected value of a constant equals to that constant. That's why we have those two equations here. So under continuous, to get the expected value, you are going to integrate from negative infinity to infinity, x times f of x, and then this is the variance, and then you do the same to get the expected value for for a function, right? So I'll show you how to apply these formulas doing examples. So for example 1, we are told that the probability of getting ahead is theta, right? And they said we should find the probability of finding a tail. So we know that it's going to be 1 minus theta. So they were like, given that x, which is a random variable, equals to the number of heads you get after tossing 4 times, so you should find the probability mass function of x, right? So x is the number of heads you get after tossing 4 times. So now the first rule when doing these questions is that you should define your x. So you define your random variables so that you can be able to answer your questions. So now here, when x equals to 0, when now you get when you do not get any heads when after tossing the coin 4 times, right? So we know that because you won't have any heads, it will be the probability of you getting tails to the power of 4. So you have you need to toss 4 times, right? So it's like you saying 4 choose 0 heads, right? And now the probability of getting a tail to the power of 4, because you won't have any heads. So this is a probability if you get one head. So you will say 4 choose 1 times the probability of the head times 1 minus theta to the power of 3. So you'll do the probabilities so on. So to see if your probability mass function is correct, you can add up the probabilities you got, can add them up and then check if you really get 1. So if you get 1 by adding them, you know that your mass function is correct. So example 2, it was talking about a box having 3 red and 2 blue balls drawn without replacement until red is drawn. So here our x, which is the random variable, was equals to the number of trials until a red ball is drawn. So I'm not going to do this how we got this. Please do it and check if you get the same answers, right? So here I was just checking if this probability mass function is correct by summing all the probabilities and checking if I get 1. So I want to show you how to use the formula for expected value. So we know that for discrete, the expected value is the summation of x times f of x, which is the probability. So the expected value for this, we are going to say 0 times 0 plus 1 times 0.6 plus 2 times 0.3 plus 3 times 0.1, and the answer we get is our expected value. So this only applies when they tell you that our RV is discrete, right? Okay, also we have this example here. So we are given this table, told to find these 2 unknowns or variables or whatever. So we are given that the expected value is 2.5. So r is the random variable, so the expected value of r is this. So to solve for the unknowns, we know that to solve for the expected value of a discrete RV, you are going to say x times probability there and then that. So we know that this should give us the given expected value. Then after that, you will find your first equation, and after finding your first equation, you know that the probability mass function, when you add them up, you should get 1. So you are going to add them up and show that you are going to get 1. This will be your second equation. Then you have two unknowns, two equations. You can solve for the unknowns, right? So okay, here we have an example from the continuous random variables. Excuse the mess, guys, but ish. Yeah, so our X was the daily load carried by 1-ton truck. So you can see that we are given the probability density function. You can see this is a small f, it's not the CDF. So we are given that this applies for when X is greater than or equals to 3/5, or less than or equals to 6/5, and anywhere else is 0. So we are told that this is a constant. So we are told that the question was that we should solve for the constant. So what we are going to do, because we know that this is a probability density function, we know that the integration of the probability density function from negative infinity to infinity should give you 1, right? So now okay, we can see that our formula is also taking what? The absolute values. So you can see that this formula after 1, this formula will start being negative, right? So if you just integrate from here to here, some other numbers will minus each other, and you won't get the number that you are supposed to get. So the sorry for the mess, guys. So we know that we want this. Why didn't I write more? So we know that we want the probability of X, the random variable, when it is greater than or equals to 3/5 and less than or equals to 6/5. So because we saw that so we are going to split our integration. We are going to say from 3/5 to 1, right? Because we know that after when X is 1, this goes to 0, and after 1, this will start being negative. So we are going to swap the equation so that we can get a positive number, since they want the absolute number. So we will say plus from 1 to 6/5. You see we've swapped what is in the absolute value bracket, and this should give you 1. So after integrating and getting this, you will solve for your lambda, and lambda will be equals to this. So you just have to check your formula and make sure that you understand, and yeah, if there's a need for you to split, just split them, guys, and swap the equations and then solve for your lambda. And guys, it's better to do like these things in the textbook. I think the textbook also explains better, like you get to understand better like what's going on, see the basics, where other things are coming from. So please, when you get time, do check the textbook and go through the examples there and stuff. another similar example. The questions are the same, it's just that they changed the numbers. I just want to show you how we found the expected value. So we know that for the expected value of continuous RVs, we're going to use this formula, right? This formula here. So when we are doing the expected value, we will use the same what we will use the same integrals that we used when we were solving for the probability density function. Maybe if we were solving for the unknown, we will use the same integrals, guys. So x is still the unknown. Okay, we're going to have x times the probability density function dx. We'll take this from 2. Remember, they gave us this formula. They said it applies from 2 to until 4. So from 2, and we will integrate from 2 to 3.5, because you can see that if you use x greater than 3.5, this will start being negative. So we'll end it at 3.5, then we'll add the part where we take it from 3.5 to the last to the last number there, or the maximum number, and then we will swap what's in the brackets and we integrate and get our expected value, guys, for continuous random variables. Okay, guys, that's it for this video. Please do examples. In the textbook, they explain this part much better, and you get to understand, know how you draw the CDF thing, know how to check them, know how to apply them. Like, it helps